In this video, we're going to look at the problems in the 14.4 slides. I'm going to start here on page 3, where we're asked to determine the value or values that must be excluded as possible solutions for each of these equations. So we'll start with this one, 1 over x plus 1/2 equals 5. And remember that when we're looking for excluded values, we look for anything that would make any denominator 0. There is only one denominator that can be 0, and that is x, so we have to exclude x equals 0. In B, we've got 1 that's x and 1 that's x minus 3. So we certainly have to exclude x equals 0. But we also have to exclude x minus 3 equals 0 as well. So if x minus 3 equals 0, then x equals 0. So 3 also must be excluded. Here, we have 1 over x plus 2 plus 1 over x minus 2 equals 1/4. Well then, we have to exclude the solutions to x plus 2 equals 0 and x minus 2 equals 0. So x plus 2 equals 0 means x equals -2. X minus 2 equals 0 means x equals +2. So exclude x equals plus or minus 2. Finally, we've got this one where we've got 3x over x plus 2 equals 3 minus 5 over 2x. And so we've got this x plus 2 and this 2x, and we have to solve each of these. If x plus 2 equals 0, we've already seen that x equals -2. If 2x equals 0, then x equals 0. So we have to exclude x equals -2 or 0 from consideration. Moving on. Sorry about that. There we go. Okay, in this next set of problems, we're asked to determine, sorry, this is the wrong slide. There we go, that's better. We're supposed to solve these rational equations and check the solutions. We start off with this equation 2 over y plus 1/3 equals 1. Well then, I'll subtract the 1/3 from both sides. There are a couple ways of going about this, and the way that the book suggests is probably the one I should use. So I'm going to multiply everything by 3y. If I multiply numerator and denominator, if I multiply 2 by 3y, I get 6. Multiply 1/3 by 3y, I get Sorry, excuse me. If I multiply 1/3 by 3y, I get y. And if I multiply 1 by 3y, I get 3y. Okay, so now I'm going to, subtract y from both sides and get 6 equals 2y. So then y equals 3 is our solution. Our only excluded value would be 0, so we don't have to worry about that. We plug in y here, and we see that 2/3 plus 1/3 is indeed equal to 1. Next, 2 over y minus 2 equals 4 over y plus 2. So I cross multiply. That's going to be the easiest thing here. I'll multiply 2 times, and note that I can't have a solution of either positive or -2. So cross multiplying, I get 2 times y plus 2 equals 4 times y minus 2. Okay, well that's 2y plus 4 equals 4y minus 8. I will subtract 2y from both sides and add 8 to both sides, which gives me 12 equals 2y, so y equals 6. Now we check. 2 over 6 minus 2 is 2 over 4, which is 1/2. 4 over 6 plus 2 is 4 over 8, which is equal to 1/2. So yes, that works. Okay, for C here, our excluded value is only 2. I have to exclude the value 2. Also, since everything here has a denominator of x minus 2, I can multiply everything by x minus 2 and get 5 minus 3x equals -1. Okay, well, if I get 5 minus 3x equals -1, that's -3x equals -6. Divide both sides by 3, and x equals -3, and x equals +2. But +2 is our excluded value, so there are no solutions to this equation. Next up, in this next problem, Nurse Vance can prepare dosages for her patients in 30 minutes. She gets help from assistants who work at the same rate. Together, they can complete the preparation in 5 minutes. How many assistants helped her? Well, this comes down to this equation here, 30 over a plus 1 equals 5. So I can multiply both sides of the equation by a plus 1, and note that I can't have a equals -1, which isn't a problem since we're talking about a positive number of people. Multiplying both sides of the equation by a plus 1, I get 30 equals 5 times a plus 1. Divide both sides by 5 to get 6 equals a plus 1. Subtract 1 to get a equals 5. She was helped by 5 people. For our last set of problems, we're asked to solve these inequalities and write the solution symbolically on the number line and in interval notation. Okay, so we start off with x plus 2 over x minus 5. Notice that this has a 0 when x equals -2, and it's undefined when x equals 5. So we need to check values less than -2, between -2 and 5, and greater than 5. So we start with, I will start with, let's say -3. If I plug in a -3 for x, -3 plus 2 divided by -3 minus 5 gives us -1 over -8, which is 1/8, which is greater than 0. I pick something between -2 and 5. I'll use 0. That's always a good one when we have access to it. So 0 plus 2 over 0 minus 5 is -2/5. That's less than 0. And then pick something greater than 5. We'll use 6. 6 plus 2 over 6 minus 5 is 8 over 1, which is +8, which is greater than 0. Now, by doing this, we've solved both of these problems here. The solution to our first problem, the solution set that we're looking for is, let's see, -2 is less than x is less than 5. We can also draw this on a number line. Make that our 0. Here's our 5, and here's our -2. So this is open at both ends. And that's established on the number line. And for our interval, that would be -2, 5. Okay, for the second problem, x plus 2 over x minus 5 is greater than or equal to 0. We get x is less than -2, less than or equal to -2, and x is greater than 5 are both parts of this solution. If we draw it on the number line, this is closed at -2 because -2 is part of the solution. And here is 5 right here. It's open at 5 because 5 itself is not part of the solution. And finally, we get our intervals -∞ to -2, union 5 to +∞. That's it for this video. If you have any questions, please get in touch.